Good day, everyone. This is Chris with the Ancient Scholar, and I'm kind of stuck here in my office. Got under some flood advisories. Raining really hard. So I figured what I'd do is do a quick video talking about cyanide toxicity real quick. So I've got some stuff set up on the table here. Might as well show you guys what's up. All right, so cyanide. Pretty simple molecule. Okay, you got a carbon atom, triple bonded to a nitrogen atom, Cn. This generally has an extra electron, so it's a negatively charged. And so you often see cyanide associated with a positively charged ion like hydrogen cyanide, HCN, or sometimes you may even see something like potassium cyanide, KCM. Either way, it's this guy here that's toxic. It's a cyanide molecule. That's what cyanide is. Cyanide is literally this little guy here. It may be associated with a positively charged ion, such as hydrogen, potassium. It's a pretty weak acid. It's not really it's a very weak acid. Its pKa is not really significant, but it can donate that hydrogen and become an acid. You also have what are called cyanogens. And cyanogens are broadly defined as cyanide, like with two units. So you may have like two cyanides bound to one another like this. So you have a cyanide here, and these can split, and then you have individual cyanide molecules. You can also halogenate your cyanide. For example, I can have chlorine, okay, or I can have maybe something like bromine, okay, or chlorine. And anytime you have these two unit kind of things going on, bromine, either halogenate it or you actually have a carbon backbone like this. We call that a cyanogen. Where does cyanide come from? Well, it's actually pretty common in nature. We see cyanide occur in lots of different pitted fruits and nuts. See things like peach pits and bitter almonds and things of that nature. There's actually a substance called amygdalin, and amygdalin has you kind of have a big benzene ring and a carbon chain comes off of that, and then you have your cyanide group, and your cyanide group can get cleaved off of that amygdalin molecule and be released in free cyanide. So eating too much of that stuff could potentially cause cyanide toxicity. And you know, when you talk about the use of cyanide, you know, the use of cyanide goes back quite a ways to ancient Greece, ancient Rome, where you know, the Romans used cyanide as a poison to actually poison people. So yeah, there you have it. So what's the pathophysiology of cyanide? Well, the pathophysiology is pretty interesting, actually. Cyanide tends to coordinate with metals, particularly iron, and so it's really tempting to say that cyanide must coordinate with the hemoglobin of your blood, which it can, but its affinity, there's a pretty weak affinity. The cyanide ion doesn't particularly like to coordinate very well with hemoglobin in its I guess you could say its natural state, if you will, in its ferrous or its +2 oxidation state. If you have met hemoglobin that's in its +3 oxidation state or its ferric state, then cyanide might have there'll be much higher affinity for cyanide. So it's not a conventional quote-unquote blood agent in the conventional sense that it poisons the blood. Really where this works is because it likes to coordinate with iron in its +3 oxidation state, it's much easier to get into the cells where you have your electron transport chain, and within the electron transport chain you have the different cytochromes, specifically cytochrome C oxidase, which is the final electron acceptor. It's able to move electrons over to the oxygen molecule. And in doing that, it's changing its oxidation state quite a bit. So it's statistically, if you look at the kinetics, the kinetics and thermodynamics of what's going on, it's just statistically more likely that you're going to find a cytochrome C oxidase in the proper oxidation state. And this little guy can get in there, and it can coordinate with cytochrome C oxidase, prevent cytochrome C oxidase from accepting electrons. That decouples oxidative phosphorylation, and you essentially cut off aerobic respiration. Your cells are unable to produce adenosine triphosphate aerobically. All you have is glycolysis. A lot of different types of cells in your body are pretty resilient and can undergo some degree of anaerobic metabolism. Unfortunately, cells in your heart, neurons in your brain, don't do well with ischemia, and so in significant cyanide toxicity, those particular systems are involved, and you can have pretty significant neurological effects: altered mental status, seizures, coma, death, cardiovascular collapse, cardiovascular instability. And if you don't treat significant cyanide toxicity within a few minutes, the prognosis is not good. And even people that do get treated pretty quickly go on to can have some long-term neurological and cardiovascular sequelae as a result of those tissues being ischemic. You have a lot of different changes there. So pretty significant morbidity, mortality. If you can get to somebody in time, the treatment, in addition to ABC stabilization, supportive care, it is going to include one of two different ways. The traditional way involves giving a nitrate like amyl nitrate or sodium nitrate to basically poison the blood, to convert hemoglobin into its methemoglobin state, the +3 oxidation state, and that's going to mean that hemoglobin is going to have a much higher affinity for the cyanide, and the cyanide is going to pop off of the cytochrome C oxidase, and it's going to complex with the with this methemoglobin. And so that's a good thing in that you can reactivate oxidative phosphorylation, but it's a bad thing because methemoglobin is poisoned hemoglobin, and it doesn't like oxygen very much. So then you have to administer, things like, methylene blues, sodium thiosulfate, things like that to treat the methemoglobinemia and to ultimately get rid of the cyanide. So it's kind of a two-step process and involves kind of poisoning. One of the newer and pretty effective treatments that I can see, that there's not a whole lot of literature that compares it to the old cyanide antidote kit with the amyl nitrate and all that, is actually a B vitamin, a derivative of B vitamin, hydroxycobalamin. And hydroxycobalamin actually contains a cobalt atom, and that cobalt atom is in a nice oxidation state that allows the cyanide to complex with that, and then that can actually be eliminated in the urine quite easily. So hydroxycobalamin, it's pretty safe. It's a B vitamin, so its safety profile is really high. It's really effective. You pee it off. You don't have these huge significant side effects. You're not making methemoglobin. So yeah, actually in this state, that's actually on the scope of practice for EMS professionals to administer. So that would be our primary agent pre-hospital-wise here in this state. Pretty effective, pretty safe, pretty good deal. Okay, where are some other places where cyanide comes from? Well, cyanide, any kind of organic combustion, anytime you have carbons and nitrogens, any organic hydrocarbony kind of stuff, plastics and vinyls and things like that. So house fires, industrial fires. If you have somebody gets pulled off fire and they're acting kind of funny, you have to, in addition to carbon monoxide toxicity, you always have to think about cyanide. And it's something that not a lot of people think about, but it should be. And then, of course, it can be weaponized as well. It's not as effective weaponized. It was used a couple times in World War One, but you know, it's fairly light, so it kind of dissipates rather quickly. It's really volatile, so it's not a great weaponized agent unless you release it in kind of an enclosed area. A lot of intentional ingestions occur. It's commonly used by people to poison other people. So, yeah, it's common in that sense. You know, people ingest it and attempted suicide and things of that nature. And there you have it. That's cyanide. It's interesting. It's pretty simple, but very effective because it's good at shutting down oxidative phosphorylation. It's really good at hitting those tissues that are very sensitive to ischemia. A really bad deal if you cannot treat it right away. Okay, guys, I'm going to go ahead and cut off here. Thanks for, as always, thanks for hanging in there.